Everyone is talking about loop engineering right now, but most diagrams stop when the code is generated. In a production AI application, there are actually two loops. The build loop is the one that everyone shows. An agent plans, writes code, tests it, fixes what failed, and goes around again. The runtime loop is the one that your company actually depends on. A user submits a request. The application retrieves context, calls a model, takes an action, and records what happened. That second loop is where your data, credentials, latency, and model spend live. This video is about 5 stages that connect both loops: access, context, build, deploy, and observe. I'm going to build an AI assistant for furniture assembly to make the stages concrete. But the same architecture can be adapted to many enterprise workflows. Everything is available in the GitHub repository, so you can follow along and adapt the project to your own use case. Here's what I keep seeing when AI applications reach production. A lot of them not secured because credentials end up pasted into code that dozens of people can access. They're not governed because nobody can clearly tell you which model answered, what it cost, or what action it took and why. And they are not integrated, so the application sits besides the business instead operating inside it. And most of these problems are not model quality problems. They are architecture decisions that you need to make before you write anything. And that's what these 5 stages designed to address. So here's what we are building. The product manuals live inside Amazon S3. A Databricks parses them and stores the content into Delta table. When a customer asks a question, the application retrieves the relevant content and sends the grounded request through Databricks Unity AI Gateway to the model we selected. So this is a retrieval augmented generation. From the application, we can compare models, open the original PDF through a temporary S3 URL, and escalate anything unresolved to Slack. So I choose Superblocks to build it because it provides the integration and governance layer this architecture needs. Centrally managed connections, governed access to business systems, and the option to run the application inside the company's own cloud environment. The application runtime can run inside your own AWS account and VPC. Stage 1 is access, and this principle applies to any architecture. Decide what the application is allowed to reach before you build it, and keep credentials out of the code. Before I started, I listed every system this application needs to touch. In Superblocks, then I opened the Integration tab, clicked plus sign, and selected the integration I wanted to add. So here I can add Amazon S3, then enter credentials required, and I can test the connection. I can also configure separate development and production profiles so that the application doesn't use production credentials while I'm still building. Once the test succeeds, I click Create and the connection is ready. I repeat the same process for Databricks and Slack. What matters here is how the build agent can use these integrations without exposing the raw credentials in the code base or GitHub repository or prompt. So you configure access once and everything built afterwards starts with an approved connection. Stage 2 is context, and the principle is simple. An agent forced to guess your project will eventually guess it wrong. The most common mistake in agentic development is beginning with something vague like build me an AI support application. Instead, I start in plan mode, which is read-only. The agent can inspect the integrations and schemas, run sample queries, ask clarifying questions, but it cannot change anything yet. It needs to understand where the manuals are stored, how the Delta table is structured, which models are available, and what should happen when it cannot answer a customer's question. From that context, it then creates an implementation plan that I can review and edit. That plan becomes the specification. Let the agent inspect the environment and write the plan before it writes the code. Stage 3 is build. And there are two things worth watching. The first is which model does the work. Not every development task needs a frontier model. Complex planning and code generation may benefit from one, but a rename or a small transformation often does not. Paying frontier model rates for every task is how AI development costs get out of control. Superblocks Smart Router matches each development task with an appropriate model, which is a decision you would otherwise need to make manually for every request. The second thing to watch is what happens after the code exists. The agent tests the API it creates, checks runtime and console errors, and confirms the interface rendered correctly. So it builds, tests, fixes what failed, and goes around again. That is the build loop. But the agent that creates the work should not be the only one checking it. At publish time, a separate set of security agents inspects the actual application artifact for vulnerable dependencies, leaked secrets, and insecure code patterns. If one finds a vulnerable package, it goes back to the build agent and gets fixed before the app is deployed. The project is connected to a GitHub from the first generation, so it's not a prototype that trapped inside a browser tab. It is a version control code that the team can review, branch, and extend. Stage 4 is deploy. And the question it answers, where does the runtime actually live? Publishing may take one click. But for most companies, the most important question is what happens after that click? Where do the API calls execute? How does the application reach private systems? And does the company data need to leave the existing cloud environment? Superblocks supports a hybrid deployment architecture that separates control plane from the data plane. The control plane manages the application definition and configuration, while the data plane can run inside your company's own AWS account and VPC. Superblocks calls this Cloud-Prem. And it's not only the runtime. Each app gets its own isolated database inside your AWS VPC, with dev to prod migrations handled for you. The app inherits your network, identity, encryption, and audit controls, and your users come in through the SSO you already use. That means the application can execute closer to private APIs, internal databases, and other systems that don't need to be exposed to the public internet. The runtime can stay within the company's network and security boundaries, while the team continues using Superblocks to build and manage the application. That distinction is worth considering with any platform. Do not ask only whether the application can be deployed. Ask where the runtime executes, where the data travels, and which side of your network boundary each component lives on. And the final stage is observe. Now it's time to run the application. I select product and then send the same question. What tools are required for assembly? So now it's been routed to two different models through Databricks Unity AI Gateway. The application can access open weight and proprietary models through one governed layer. Both models receive the same context from manual, and their answers appeared side by side with latency and token usage. One model may provide a stronger answer, but take longer and use more tokens. Another may be faster and less expensive, while still being accurate enough for a routine support question. That is why observability closes the loop. The information we collect in production becomes context for the next build cycle. We can update application, change models, improve retrieval, or add new validation steps based on what actually happened, not what we assumed would have happened. At runtime, I can also see all the requests are being logged into a system table, so I can expect traffic coming from this application, including request volume, latency, token usage, and failure rates. Once every request is traceable and measurable, model selection and application performance become something that your team can query, improve, and govern instead of debate. Now, let's talk about MCP connections. You can monitor every build, every integration access, every package install, and who accessed what. Your IT team can query all of this from any AI assistant through the Superblocks MCP. They can see which app exists, who built them, and what data they touch. Those are the 5 stages: access, context, build, deploy, and observe. Together, these stages connect two loops. The build loop creates and verifies the application. The runtime loop retrieves context, calls models, takes action, and decides what to do next. What we learn in production then becomes context for next build cycle. So the application keeps improving based on real evidence rather than assumptions. Everything is available in the GitHub repo, including Superblocks app, sample menus, and setup instructions. Clone it, replace the sample documents with your own data, connect to your workspace, and use the architecture as a starting point for your next enterprise AI application. And as always, happy building!